Okay, so we are doing well, right? So today I hope to talk about something new with my earlier data set, right? So this will be an extension of Weinberg. So last time I was talking about a classification model named K-nearest neighbor, explained mathematical inclusion of that and how to train the model. And we have uh, evaluated the model as well. So today I'll try my best to cover entire region of K-means clustering, right? So this is a kind of unsupervised machine learning algorithm. So what we do using this K-means clustering, and what about the mathematical intuition behind this? Let's see, right? Okay. So I'm not good in presenting, but I'll try my best, right? So here, when you have some numerical data, when you have some raw data with a couple of attributes, right? There are so many famous data sets, Iris data set and Balloon data sets. Likewise, there are some more researchers behind them. They have carried out them uh, in order to clusterize them. When they have collected these data sets, the the author has the idea of finding some clusters, some of those in some of those data sets, not in each of your data sets, right? So we can go through some more machine learning models using this data, using a single data set. But in some data sets, when they collect these data sets, they had the idea of doing some classifications, doing some clustering, doing some regressions, some more things like that. But in some data sets, they are adapted for clustering, right? So the desire was to find out some clusters and cover some clusters, right? So like this, I think on my right. Okay, here. So clusters, right? So how do you find out these clusters? That's what I'm going to show you. There are a couple of methods. K-means is one of the method behind that, right? Under that. So K-means clustering is applied for numerical data frequently because this standard format is invented by I don't remember those names, but I have written them over there. Harding and One. The standard format is invented by Harding and One. As I remember, it is in 1979, around that, right? Um, so this can be used for clustering numerical data. Now I'm going to show you how to do this. Right. This is not a full explanation. This will be a better one. I'll try my best to emphasize the idea, right? So here, uh, we are having so many data in the data set, right? So we don't know how many clusters are there, right? We don't know how many clusters are there. So the first parameter is withinness, right? Withinness of the variation of each data. Xi is an element of these clusters. It's a measure of the square of these distances. These are Euclidean distances, right? Square of some of the square of these Euclidean distances are known as withinness, right? So it's withinness. Its withinness is a measure of clusters, right? So we want to find out total withinness This case, nothing else, number of clusters, right? Let's say there are two clusters and k equals 2, right? So we have to find out total withiness from 1 to k. If there are two clusters, they should be run from 1 to k is from 1 to 2. If there are 10 clusters, it should be k is from 1 to 10 like that, right? So k is from 1 to k, we don't know how many clusters are there exactly. So it will be how to find out exactly how to find out these clusters. If you are trying to do them manually, each of these it will take a lot of time, right? These sum of squares of these Euclidean distances, right? These are observations of clusters. These are each arithmetic means of each clusters, right? If there are two clusters, there will be two arithmetic means corresponding to those clusters. They are known as means of centroids, right? They are corresponding to centroids. Likewise, we can find out total withiness. This is nothing else. Total withiness. Total withiness can be derived using withiness, right? This is a good measure of finding out clusters. We want to make it as small as, right? We want it to be as small as, right? So I feel like I am too small. So, right, okay, now you can see me because you always are far away from me. Therefore, I have maximized, right? Okay. Uh, this is the mathematical intuition, right? So I want to explain some more things. These questions I need mind, right? How do we find out this number of clusters? Let's imagine there are two clusters. It's like that, as I explained. If there are three clusters, it should be k should be replaced with 3, right? So how do we find out these clusters exactly when we start this journey? Yeah, that's the question, right? So there is a method. We can check it with a couple of clusters from 1 to 10, right? We can, 1 means it's just the entire answer, there is no mean, right? It does not make sense because everything has been put into a single cluster, right? If k equals to, it's split into two parts, but not deeply likely, right? There is no requirement to contain equal amount of elements in a cluster, right? In each cluster, the requirement, the sole requirement is, this is very important, right? So try to understand this. The sole requirement is, that all these distances may be considered, right? All these distances may be measured, right? So the correlation, uh, closest points will be assigned into the corresponding centroid, right? So this is the requirement. This is a requirement. So it's not required to be split equally likely, right? Equally likely. Okay. So let's say if we ask him to get number of clusters as 2, right? Then k equals 2, right? How is it started? We have a lot of points. Let's say I have 1,000 number of points. Out of 1,000, if k is defined as 2, what does it do is, first of all, it will pick 2 points randomly. If k is given as 2, so 2 points will be picked randomly out of 1,000 observations, right? So after that, it will be considered as centroids or means, right? Because when we start this journey, we don't have clusters, we don't have means, or we don't have centroids, right? So these randomly selected points will be considered as means. That is an assumption. So with respect to these centroids, all the other remaining points will be considered, and with respect to these centroids, the Euclidean distances may be measured, right? After finding out these Euclidean distances, the next step is to assign these points into relevant clusters. So in my example, I have taken that k equals 2, and we have two centroids. Let's say this is x5, this is x 200, right? Likewise. So all the other remaining points will be counted, all these distances will be counted, and then the closest centroid will be considered, then those points will be assigned to the corresponding closest cluster, right? Closest centroid. So likewise, actually, these randomly picked 2 points, if k equals 2, these randomly picked 2 points are not real centroids. So in order to make it a more consistent, more reliable system, what it's do is it's finding out these arithmetic means individually again based on the early step, right? Then the new centroid will be defined based on that. All the other points will be considered as remainders, remaining points. Then again, the earliest step will be repeated. It's an iteration, so we will define iterations here, right? Number of iterations. It will be stopped once these are equal. Once these are equal, it will be stopped, right? So then we can make sure whether they have been split into clusters properly or not, right? So this will be a fine method when we have unlabeled, unstructured, unlabeled dataset. When we don't know predictors and responses, this is a better method, right? Especially when we have numerical data, right? Okay. So the next question is, how do we know this much of clusters are there exactly? Yeah, that's the next question. We can see 2, 3, maybe like that, even 4, 5 like that. We can switch it, right? And we can switch it when we do it manually. You can imagine this in your mind, right? When k equals, right? When k equals 2, what is the total willingness? It represents the compactness, right? When k equals 2, we can count the compactness, right? Or goodness of this data, right? Compactness, if there are some more spaces between these points geometrically, they are not good clusters, right? So I said that earlier, this total withiness, this indicator must be, we want it to be as small as, right? We want it to be a small value, right? So we can take it with k equals 2, k equals 3, k equals 4 like that. If you are doing it manually, you will be tired of doing this. Even thinking of this, right? So I'm going to show you how to do it using Schrodinger, right? Okay, so let me share my screen. So like even last time I tried to do this, I'm trying to review the presentation, but yeah, actually I was scared of this. I tried to present you this because, but my laptop was stuck and I had to cancel it. Right. Okay. This should be the second time, right? Okay. Uh, okay. Now, these are my audio was range preparation, right? Here. Now, we need library. We need library. Yeah, there is a line. um, we need to load facto extra libraries needed there, right? Now, okay, I'll load it. In addition to that, library ggplot2 is required to be loaded with that. If we needed to visualize something, we will use ggplot as well, right? So now, first of all, we have to scale the entire dataset, otherwise these distances cannot be found. These distances can be found out, but it doesn't make sense. It is meaningless, right? Because they are spread out in different ranges. That's why, right? So just like my earlier k nearest neighbor classification, in this case also we have to scale, right? So last time I have distinguished the scale and the even we can make it using the user-defined function, right? Scale function is based on normal distribution, right? If you wanna scale it based on minimum and maximum value, it is something different. But this scale, this default scale function is talking about normalization, right? Okay, so I'll call wine scale, scale, wine, right? I'll scale each of every columns. Now I will find out how many clusters should be there, right? First of all, I'll set seed, right? Set dot set dot seed with my lucky number, right? Let's try it with my lucky number now. Okay, I want to find out. I want to find out if this NB cluster should be there, right? So you want to work with wine scale dataset, right? Scale dataset. This total within will be computed, and in order to make it an optimal value, it should be decreased, right? Uh, I don't want to include a large column window. It includes the color, right? So I don't want to make it a bias system. Therefore, I have eliminated. I have excluded that large column color from the this kind of computation, right? Okay, K means and the method. There are a couple of methods, and at this moment I'll use elbow method, right? WSS. Right. Okay. Let's see how many classes will be there. How many classes are appropriate for establishing? And based on this answer, we will go forward, right? Yeah, it's been run until that. I'll stop recording until until the results come in, because I'm not going to edit this. Therefore, I want to make this short as much as. Yeah, okay, right? So this is the result corresponding to for this last code. This is the result. It's giving us the idea of optimal numbers of clusters. So we want to make it smaller, right? To it's smaller, but you can see according to this graph, the ideal value is just 9, but we want to make it make number of clusters. Uh, it should not be a large amount, right? If it's coming out with a large amount, it's too difficult to classify meaningfully, right? So therefore, I'll pick 2, right? I'll pick 2 according to this graph. I'll pick 2. Even you could play it with I'll I'll switch the method, right? Switch the method is cluster nb cluster, right? Nb cluster. What's my data set by scale? K means I don't use to define the method, right? Let's see what we do inside. Yeah, according to this, this also is a kind of method, we will use for finding out optimal number of clusters. We can make sure with a couple of methods, using a couple of methods, average, affiliate with this value is inversely proportional with total index, right? So according to this, we can set a number of clusters as 2, right? So I'm going to k means find set k means clusters, right? K means what? Find scale. This is the data set. How many clusters should be there? 2 clusters, right? Height dot max. Maximum iterations I'll put here to write n star. N star is compulsory. It is not required to be set because the default value can be set as 1 in R. Though you have not said it will work, the default value has been assigned into n star. What does it mean by n star? N star means that when we start at the very beginning of this theoretical part, I explained that if we define number of clusters equals 2, randomly 2 points will be found out, right? So in this n star, if I put this as 10, within 10 randomly within 10 points this will be found out, right? So it's better to assign value larger than 1, right? As much as larger, right? Okay. Due to my lack of computation power in my laptop, therefore I will put instance 10. K mean cluster. Oh, cluster, right? Okay. Let's see. What's there? This should be k-means, and I have made a pretty small mistake. It's a pretty bad mistake. I have to exclude this last column in order to make it meaningful, right? Now it should work, right? You can see this is the result, right? So, okay. These values, these are clusters 1 and 2. These are clusters, these values are corresponding scale means centroids, right? For example, fixed acidity, scale mean will put there, right? But it is meaningless. We cannot read that. We can get an idea of why it is not readable. It is not in readable way. So I will use aggregate. I'll use to aggregate about y data should be included there by equals list cluster equals cluster k mean. What's my cluster? Okay, k mean cluster $sign cluster, right? We want to make it by mean, right? By mean, right? Okay, let's see now. Right, let's see. This is meaningful. This is meaningful, right? X. So I think number of points are considered as X. It should be eliminated, right? I think it's meaningless, right? X should be eliminated from the data frame. Somehow fixed acidity, right? Fixed acidity. These are centroids individually with respect to this one. In the first cluster, it should be 6.8, something like that, right? This is larger. Fixed acidity is larger with respect to the first cluster. In second cluster, this fixed acidity is larger. Likewise, you can compare each of them, right? pH seems like they are almost equal, the pH value, but in color you can see color there is a difference. We expected this, right? Because this is almost 0 and this is almost 1. It seems like this is white wine and this is red wine, right? Could you understand it? There are two clusters, exactly they have identified these two clusters. Let's see. Sorry, I'm trying to visualize it now, right? I'm trying to visualize it now even. Okay, I have broken it. I have done it piecewise because of my computer, right? It is stuck frequently, that's why I know what I want to do now. I can interpret this, right? Before interpreting that, I'll show you k-mean plus I will show you some more results. Individually, we can plug in these results, right? What is this? Total squared of sum of the squares. Total sum of squares, right? Total sum of squares, then k-mean plus withins. These are withins, what I explained earlier, right? So there are two clusters, that's why there are two values. With respect to those two clusters, there are two withins, then from case from 1 to 2, it should be summed together, it should be added together, then you can find out, instead of doing it manually, you could do some magics using this, right? Okay, you can see when you add them together and get the mean, right? Actually, the addition, because k is from 1 to 2, right? The addition between these two, right? Likewise, there are so many things you can play yourself when you want to understand what does it say, right? So a proper idea should be taken before running all these size of so these clusters, right? These are dimensions. Totally, we had almost 6,000 rows, I think, right? This is how they are propagated. They are split into two parts like this, right? Okay, dimension. Let me check dimensions of y, right? Dimensions of y. Next, yeah, this is this one, right? So total points are there, right? You can see the summation of these two should be 6,497, right? Exactly. So the next significant thing is to add these cluster values into my data set, into my data frame, right? I'll call this k-means, right? I'm going to add it into my wine data set, right? What is it? k-mean underscore cluster, k-mean underscore cluster, right? This is going to be added, right? Then I have print it now, wine print. But there is one more issue. There is one more issue, right? There is one more issue. What is it? k-means. Instead of 1, there is 2, right? Because it represents the number of clusters, that's why, right? So what I'm going to do is wine k-mean, right? If else while k-mean is equal to, please replace by 1, otherwise 0, right? Okay, let's see. Okay, you can see it, right? To make sure we will run a summary, I forgot one more thing. I want to visualize these two clusters nicely like this, right? Like this, like Puma did it, right? This Puma did it nicely, right? So I have to do it nicely as well, right? Okay. So somehow, while he's my pet, I have to do it nicely rather than him. Otherwise, I'll be trapped in huge trouble. Okay, so what I'm gonna do, summary of wine or KB. I will check or summary, or even you could say, yeah, okay, it doesn't matter whatever it is, library, or you could depend on library dplyr, you could count what's my data set, wine percentage, value percentage, using count, k-mean, right? Okay, using all these we can do the same. Mean value, right? Okay, count, according to count, right? Okay, somehow now I need the evaluation. Before doing the evaluation, I forgot to interpret these clusters, right? I have shown you these results, but the most attractive thing is this interpreting this cluster, right? Okay, it's been done with the help of FactorXpra, library FactorXpra. I've this cluster, right? Of this cluster using this function. I'll what's my k-mean? K-mean cluster is my cluster model, right? What's my dataset wine? Well, it can be your scale dataset, it can be your non-scale dataset, it doesn't matter, whatever it is, you should exclude this one because it is not in your dataset, right? It is not in your model, not dataset, right? Okay, we will run it and we will check the output. Right, you can see it nicely. There are two clusters exactly, right? There are two clusters exactly. So I'll show you. I'll switch this with wine. What's my scale one? Scale. Oh, let's check it. The result is not changed too much, right? Hope you could understand this, right? Okay. Scale is the normalized one, right? We have found out these clusters based on this scale. There is no difference between, there is no significant difference between scale and non-scale one. So there are two clusters exactly, depending on all these characteristics. Even we could study them individually, likewise pH value. The mean of the first cluster is 1. It stands for white wine, I think, right? You can go up and you can check. 0 stands for white wine and 1 stands for red wine, as I remember, right? Okay, so that's how I did it, right? So this is almost 0 and this is almost 1. It's pretty close to the output, right? Expected output. Okay, so finally I can evaluate this model. Oh, you can can use library caret, library caret can be used in confusion metric. Confusion metric is the function, right? Upper in confusion metric, then wine is my color. This is a real observation, and wine according to k-mean is my next. Let's see whether they are not matched. They are not in same level. Let's check the status, right? Wine, let me check it. Store numeric. What is the last one? Okay. Store factor. I have put them into the same level right now. You can see the accuracy of the model is 99.74%. So within this 95% confidence interval, it can be increased or decreased within this range. The accuracy can be maintained. So the kappa value is pretty close to 1. It's a better value, right? Positively predicted values and negative predicted values are pretty close to 1. The rate of them are pretty close to 1. It's a really good model. So you could check whether it is overfitted. Someone can say this is overfitted, then you can check it with some more seeds, right? And you can collect some more data sets, and you can use the same model, and you can clusterize it, identify it, right? Okay. So I think I can present it successfully. I'm not fluent, and I'm not expert in all these things. So if I have made something issue while I'm presenting, while I'm explaining, then you can share your idea with me, right? And I can make some changes according to them, right? So okay, so this is what I wanted to show you. Actually, today I plan to do some games with you, some web scraping, especially plan to scrap Facebook's using Facebook or any other social media using R programming. So then we can extract, let's say you are sharing some posts and you are posting videos on YouTube, right? And how do we analyze these social networks? How do we extract these comments, these likes, and how do we check whether these comments are updated or not? So many things can be analyzed. We can make some predictions. We can do some comparisons. So actually, that's what I wanted to do, but I felt like there was a guilty conscience because there are some more models behind this wine world. So you love wine, and so I wanted to uh, uh, give you some encouragement with machine learning models for wine, right? So nothing else, right? Okay. Somehow, hey, the next time I hope to show you how to describe. It's better to start with YouTube, then maybe I'll go for Facebook, right? Let's say if you do something, any post, there are some comments, right? So you wanna describe it, you wanna put those those comments, number of likes, and the number of likes and expressions given for a particular comment should be counted, and then we can make some conclusions, right? We can get an idea about the nature of these current flow, right? Current trend. Likewise, we can do so many things, right? So next time I will show